Okay, it's the second lecture of linear algebra, and again it will covering all the basic things, but while with solving the questions. We will not study like the theories directly, only we will like solve the questions, and from there we will try to catch the theories, which is the fastest way. Okay, yes, lesson 2, linear algebra. I am solving the first question of the partial exam, 9th of April 2022. So you have a matrix A of t, which is 1, -2, 2, -1, 2, -1, 3, 0, -1, 5, t, 3. And the first question is find out the rank, and it depends on your t. So there is a there is a variable that we don't know what the value will be. So do you know what is rank of a matrix? Is the number of steps that you will end up with after
leading one.
Yeah.
Okay.
Sorry.
The number of leading ones actually. The one that is when we do
the row
echelon form, we have a matrix which is 0 in the steps. Like
yeah, the row which is non-zero, you will count those. So it's basically rank is the number of steps that will end up. Okay, so I'm solving it because it's just okay. You can multiply -2 and add it over here. I am multiplying -2 to R1, and I'm adding it to R2, and also for R3 I'm just adding R1 and R2. So I want to make this to 0. So if I do that, I will end up with 1 minus 2 1, sorry, it's -1. This will be 0, this will be -3, this will be 5, and this will be -1.
For R3 you're adding R1 and R3 actually, right?
Yes. And this is 0, 3, 3, and 2 plus t plus 2, and here you got
2.
Yeah. Yes. Now you can see I can make this one 0 by adding R3 is R2 plus R3. So you will end up with 1 minus 2, 2 minus 1, no change here. 0 minus 3, 5 minus 1, no change here. 0, 0,
t plus 3.
T plus, no, you have a 5 over here. T plus 8. I don't think is correct.
T minus 3.
Yeah, it was I multiplied -2, so it's -4. Just a minute. Yeah, -4, -1. Yeah, this would be -1, I guess. Right?
Yeah, and t plus 3 then. At the end, this would be -1.
And this will be 3.
And this would be t plus 2. That's t plus 2.
And in the next step, I will add it, so it will be t plus 1. Okay, until here I am correct.
Yes.
-2. Yeah, I'm wrong. So also here, if I multiply -2 is started this one 0, this is 3, this is t plus 2, and yeah, Yes, 2. Now it's correct, I guess. And
this will become t plus 3, this is minus 1. This is 3.
it is 3 or negative 3? Yeah. Yeah, now now I'm correct. Sorry, I made some mistakes here. Okay, in the plus
So
minus.
these are correct, right? These steps.
Yeah, the steps are correct, but while I was
Plus minus.
calculating, it was a mistake. Now, since you see, I want to make this one 0, so I can write my R3 is R3 minus R2. Okay, so it will be 1, 1, negative 2, 2, negative 1, and here you will get 0, 3, negative 1, 2. Here you will get 0, 0, t plus 3, because negative of this one you get 0. So now you see, now the question is find the rank. So rank is the number of steps that you got, but now there is a trick. Your t can be if this becomes 0, so you will have 2 steps, right? If this becomes 0, so it will be like this. But
Okay.
if this is, so if t plus 3,
Steps means number of rows.
sorry, yeah,
What do you
number
mean
of
by
rows,
steps?
number of rows,
Okay.
number of rows that is non-zero. So
Number
if
of
t
rows
plus
is
3 equal to 0, your rank will be 2. If t plus 3 is not equal to 0, your rank will be 3. So when t
Right.
equals to negative 3, when t equals not equals to negative 3, yeah.
But why, like, कोई एक वो नहीं कर सकते हम, जैसे for example, can't we just choose one of the scenarios, or do we
No,
have
no, no, you have to analyze all the scenarios.
Okay.
As I said, the rank for what value of t, you have to identify them. You have to write both the solutions. Next question. It's the first bit. Okay. The next bit is consider t equals to negative 3. Okay. Consider negative t equals to negative 3 and find the solution. A negative 3x equals to u equals to v, and your v is 1, 2, minus 1. So indirectly the question is asking to solve asking to solve for a non-homogeneous equation. So I can just copy this part. If I put it over here, your t is given negative 3. So if you consider t as negative 3, this will be,
This is 3 t plus 3.
yeah, t plus 2. So if you consider this one as negative 3, so this will be negative 1.
So this wasn't t plus 3 here?
Yeah, I applied the rho epsilon form here. So if you can also, you can consider that one, but I'm not taking it right now. I'm just taking this part. Okay,
Wow.
forget about this. Now is it correct? I took it from the,
Okay, from the first.
yeah,
Okay.
and this is a non-homogeneous equation, so this is 2, this one. So
Okay.
now you need to do the rho epsilon form. Okay, as I did the first step. Do you remember what I did? Just copy it from there and you have to do the operation over here.
No,
So if I
the steps, like,
yeah.
Okay.
if I multiply negative 2 and add it over here, I will make this one 0, but you have to consider for this part as well. I am multiplying negative 2 in R1 and I am adding it to here, so
This
it will
is
get
0.
0, and for this one I am just adding both of them, so this is also 0.
Okay.
Okay,
Yeah.
and you will end up with this thing. Okay. If you do that, you will
Okay,
end up with this thing. Okay. Then I'm just adding this one. This R2 R3 is equals to R3 minus R2. So you will get 1 0 0. There will be no change here, so it's 1 minus 2 0 3 negative 1 2 0 0 0 0. If we consider now, the equation was in 4 variables. Let me check it out. Either it is x1 x2 x3 x4 or x y z t. Let me check.
X1, X2, X3, X4.
Okay, nothing is given, so I can consider all of them. So if I see is x1 x2 x3 x4, I can say x4 and x3 are free variables.
One question.
Mm-hmm.
Can we choose any of the, for example, I made equations over here.
Mm-hmm.
So for me, the most comfortable options were x2, x4, and x2 for them to be free variables.
X2
Because
how
I could
can be free variable?
Equations for x3 and x1.
But you cannot. X2 is not free here. If you get like maybe this one 0, it could have been possible, but it's not possible.
Okay. So x2 is not a free variable.
Yeah, x2 is not a free variable.
So this was wrong.
Yeah,
How do you say x3 and x4 are free variables?
because you see, I got steps until x1 and x2 is there, but x3 is not there and x4 is also not there.
Okay.
If I do the steps, x1,
you start from here. Or...
yeah, I start from x1. You start from x1. X1 is there. X2 is there.
Okay.
No x3, no x4.
Okay.
Okay, these are 0. You mean?
Yeah, and also there is one more row which is 0, which we don't see it. Okay. Then I can write the equation. This one will be 3x2 minus x3 plus 2x4 equal to 0.
Okay, now I get it. When you do the steps, you get x1 here and x2 here. There's
Okay.
x3 and x3 is here and x4 is.
X4 is there, but it's
Okay,
not.
it's not. Oh.
Yeah. So if I this is the equation I got from the second row. Okay, and if I take x2 at one side and rest of the things is x3 negative 2/3 1/3 x4. Is it okay?
Yes. I
Minus
thought that I would be complicating all this, so I just
Yeah.
took x3 as the subject and like did all that.
No.
That's fine.
I
just-
understand this one, but how do you?
I just took it from this side. I just kept
Okay.
x2 here and
Okay, you divide by
Yeah.
3.
yeah, because there was multiplied 3, so
Okay.
and here I can write x3 is equals to x3 and x4 is equals to x4.
Or 3.
Three variables, and from the first row I can write it as x1 negative x2 plus x3 negative x4 is equals to 1 from the first row.
Okay, yeah.
And yeah, then I can x1 is equals to 2x2 negative x negative 2 times of x3 positive x4 plus 1, because there is a 1 over here. Okay, which you forgot actually.
Yeah?
So there is no particular solution, that's why.
Okay, repeat.
Since there was a 1 here, because of this one you will see there will be particular
Yes,
solution will come. You just have the the homogeneous solution. So when you take everything to this side you have a 1, right?
1. This is non-homogeneous.
Yeah, this is non-homogeneous, so I can substitute the value of x2 over here. I can put this one over here.
Okay.
So if I do that, let let me change the color. It's 1 over 3 x3 minus 2 over 3 x4 negative 2 x3. Just a minute. Yeah.
The combination between x3 and x4.
Yeah, yeah.
For all of them.
So it will be 2 over 3 x3 minus 4 over 3 x4 negative 2 x3 plus x4 plus 1. And if you do it, so this one will be how much? This 2, this will be 6, so negative 4 by 3 x3. Correct me if I'm wrong, okay? And this one will be, if I take this negative 4 negative 7 over 3 x4 plus 1, right?
Yeah.
Am I correct?
Yes.
Yes, that's correct.
So my solution x1. So there will be one particular solution and there will be one solution which is depend on x3.
One particular solution is this.
Yeah.
1 0 0 0.
And yeah, and there is one solution as depend on x4 and
Okay.
my x3, yeah, x3 and x4 belongs to R. So the particular solution is this one is 1 and there is no constant in x2. You can see
How do you determine the particular solution?
is when you write the solution x1 x2 x3 x4 in this form,
Yes.
you have
Constant.
the constant 1, and when you see the equation of x2 there is no constant term.
And
It's 0 and x3
X3
is
and
equals to
x4
x3. So
okay.
and here x1 has a negative 4 over 3 x3. Okay,
So particular solutions are
correct.
Oh yeah, yes.
So you
Minus
just take the
4, right?
constant, and from x2 you get 1 over 3. Then here is 1 0 because x3 is equals to x3 and x4 is equals to x4.
Okay, so here is 0.
Here is 1 and here is 0, and if you check for the x2 equation is negative 2 over 3. It's negative 2 over 3, and for the x1 equation if you check it out is negative 4 over negative 7 over 3. So it's negative 7 over 3. So this is a solution which I got. My solution is 1 0 0 0 plus minus 4. Okay, I can multiply 3 all the sides, so it's negative 4 1 3 0. Also I can multiply 3 in all the sides, so it's negative 7 negative 2 0.
okay. This is the same thing, right? The thing you told us yesterday that we could assume x3 and x4 as s or t,
Yeah.
and that
Yeah,
would also
yeah.
be correct. Okay.
Yeah. The
It's, two vectors are linearly independent.
yeah, I can see the zeros are in different position. So
Yeah,
when you
it's
check,
correct because
Yeah.
it has to be the
Yeah.
same. These are free variables.
yeah, that's the second bit. Okay, and let's go to the
And we
third bit.
always have to write the particular
Yes.
solution. But if there is no constant, then there is no particular solution.
Yeah, it's as I said in the last class, we have two possibilities: homogeneous equation and non-homogeneous equation. And a homogeneous equation doesn't have a particular solution because it doesn't have any constant terms. Let's do the third bit. It's saying again consider, you can read the question here. Again consider t equals to negative 3 and u equals to 2 alpha 0, where alpha belongs to R. Okay, and find any alpha if the solution is there or no. Okay, did you read the question?
Consider the various vectors u to alpha 0. So alpha is a value in real
Yeah.
number.
Yeah.
So it can be anything.
Yeah. So it's like doing the second step with a different
Okay,
U.
this is the same linear system.
Yeah. So I can, to avoid a lot of writings, I can just copy this one here.
The vector is
Did you understand?
Oh yes, this is the same as last one, but they changed the vector.
Yes.
Actually.
Now you can see here. I just copy and I paste it over here. I have to change this one as how much? 2 alpha 0. Okay. First operation, you remember, I have to multiply -2 and add it over here, and I have to add it just this one over here that we did. So it's 1 -2 2 -1 2, no change here, 0
3.
So I can copy this one. Okay, and here there will be alpha -4
Yes.
because
Okay,
I'm
yeah.
multiplying -2 and add it over here. Okay, and here it will be 2,
2.
correct?
You're adding the first row here.
Yeah, the steps I did
Okay,
last
okay,
time.
the same.
I did like, yeah, and now I can add it this 2,
Yes, can actually.
1 -2 2 -1 2 0 3 -1 2 alpha -4 and 0 0 0 0, and here is alpha -4 plus 2 is -2.
Oh.
Okay,
You subtract the
Oh.
third row
Yeah.
from the second.
no, I added. No,
Yeah.
no, yeah, you are
So
correct. You are
subtract.
correct. 6.
Okay.
So if I subtract, also there will be
This
minus.
is 2.
Yeah, it is 2.
Okay, 2.
Yeah, negative alpha, positive
2 minus
2 plus 4. It's
2 minus 4. It's minus 2.
Alpha minus 2. Alpha minus
Alpha
6.
minus 2.
Alpha minus 6.
Minus 6. So you're subtracting the third row.
I'm doing negative R2 plus R3.
Okay.
So
So that's equal to R3 minus R3.
yeah,
So 2 minus this.
yeah. It's not the same.
It's the same
I
as
just
alpha minus alpha plus 6. That's right?
Yeah, but if I multiply negative over here is minus alpha plus 4, then I'm adding 2, so it's negative alpha plus 6. Now
This makes
I'm
confusion. That's correct. This is 2.
yeah, this is 2.
Okay.
Now is it
That's fair
correct?
enough, yeah.
So as I said in the last class, if you get this condition,
No solution.
This is no solution.
no, you have to analyze. That's the analysis mathematics. If negative alpha plus 6 equal to 0, there is solution. So if alpha equals to 6, you have a solution. If alpha not equal to 6, no solution.
Okay, that's correct. But if the first case, all solutions should be 0.
But if we didn't have alpha over here, there would be
Yeah.
no solution.
Can you repeat your
When we have alpha equal to 6,
6?
We
All
have
the
zero.
line will be 0 0 0 0 0. So we will have free variables.
free variables.
We will solve the equation, so there will be a solution. But
Okay.
if your alpha is not equal to 6, it will be like 0 0 0 0 1 here.
This does
So
not have a solution.
0 cannot be equal to 1, so yeah. Understood?
Yeah.
Easy? Okay. Now, does it exist a t such that the homogeneous system zero vector solution has a unique solution x equal to 0, the answers will be justified. Okay, coming back to last lecture that we have discussed, our homogeneous case has two possibilities: infinitely many solution, in the other case a trivial solution, right? That is
Right.
zero vector. If you see the last notes, you will get it. So it is asking about whether there is some value t. For that you will get only this case, not any other case. Has only a unique solution, is this one.
Yeah, since we have two cases, this one can address this. The zero vector is always the answer of the homogeneous.
So it's basically asking about this one: 1, -2, 2, -1, 2, -1, 3, 0, -1, 5, t, 3. When you solve this equation, like when you solve it with x1, x2, x3, x4 equals to 0, right, you will first do the epsilon form and everything that I have already did in the first question. So let me just copy paste it from here. Copy, x1, x2, x3, x4 equal to 0. So if I write the equation, x4 is equals to x4, right?
X4 is, this is the row echelon form.
Yeah,
So it's again two cases. If he's
yeah. So imagine if this will be 0, if this will be 0, if t plus 3 is equal to 0, if t equals to -3, you will get also x3 equals to x3, right?
okay, yes, because yeah, we have discussed this. Actually, we have two free
Yeah,
variables.
but
x3 and
since the
x4.
question asked once again, I am discussing once again. So now you will have, something like some solution which is depend on x4, x3, and some solution which is on x4, right?
In this case, yeah.
In this case,
Okay.
if your t plus 3 is not equal to 0,
Then we have only x4. then.
only x4, anyway you will have infinite many solutions, right?
Yeah, that's right.
No matter whatever the t value is.
मैं zone out हो गया था तो मैंने पूरा
Okay, so as we analyzed in the first question, if you see, if t plus 3, if this becomes 0, you will have two free variables, one is x4 and the other one is
this
x3.
is row echelon form.
Yeah, 0 epsilon.
And when does it is a such a t homogeneous system 80x is equal to 0.
It is asking, is there any possible that for any value of t, is there any value of t for that you will get a unique solution? We're analyzing for that. So first case that I'm analyzing, if this one becomes 0.
How do you know x1, x2, x3, x4 is because of this x?
Yeah.
Okay.
So I just writing it, and if you get this one 0, you will have two free variables. That means your solution will be some combination of two free variables, right? It will have infinitely many solutions.
Yeah, but can't we solve this and just write the solutions that way?
We don't need to do it actually. It is just asking, does it has any value? Just justify your answer.
Okay.
It is not asking you to do it.
Okay.
So neither wasting time, you just use your concept, the theory that you have, and you answer this question. So
it's asking for a unique solution which is a zero vector.
is there any exist?
Is there any? No, you're actually analyzing the value of t which satisfies this condition.
Yeah.
So it's actually the second possibility.
No.
Actually,
Wait. Now you see, in this case, when t plus 3 equal to 0, you have two free variables. infinitely many
Okay,
solutions. I don't know what will be the value. If t plus 3 is not equal to 0, you will have one free variable, right? x4.
Yeah, right.
Again is infinitely many solution.
Infinitely.
So there is no value exist. This answer to this question is no.
Oh, because there are always infinitely many
Yeah,
solutions.
because anyway there
There's
will be
no other possibility.
yeah, no other possibility.
How would we get a unique solution?
If there will okay, did you solve the example that I gave to you? Did you check my PDF?
Example.
That's why I said
Okay, I understand. If there are no free variables,
where it was here.
no free variables would be equal to a unique solution.
Yes, so if you try to observe, no, there were some exercises. Okay, I think I have given to you the papers.
Okay, yeah.
Yeah. But carefully see this one. I have solved this exercise last class. Yeah. So, answer to your question, why, how you will get a unique solution in non-homogeneous part. No, I'm giving you the answer. You have to solve these 5 exercises to get your answer. So can you click the picture of this exercises and
We haven't solved
Got
any
the
in
way.
the yesterday.
The theory.
नहीं अच्छी practice है.
Solve this one. I remember.
No, this one we solved.
Okay, the
this 5.
this one.
The last question, 6th one.
Okay.
I will give you 2 different methods. First method, like in the first half of the course. Second method, you will learn it after understanding orthogonals vector. So there are 2 ways to do it.
Of the first phase,
Yeah.
my approach.
Yeah.
So we have to find a value for like here. We have a
We will go
like
to
a
the
solution,
question.
but not the equation here of
Yeah,
W.
yeah.
So does there exist any like alpha, beta, and I don't know.
No, wait.
Okay.
It's a different thing.
Okay. So
Okay, first, did you understood the first question or not?
the first question.
The question that we solved now
Yes.
completely.
Can I see the question?
This was the first question that we solved.
Oh yeah. I actually did. All 4 parts are.
Perfect.
Yes.
And second question I solved last class. Okay, so you can go through the solution completely, and also since you didn't attend, I have the video.
Okay.
So I will share you the video. I solved every question except this last one because I want to give more emphasis. I will solve it like at the end so that you will have a clear idea. It's the same question. Write the linear system in the unknowns x1, x2, x3, x4 to solution at W. It means equation
The
of
6th one.
yeah.
So here is the 5th.
Yeah, you identify. First
yeah.
question is U and W. Second question is U intersection W, and third question I have done this one 2 questions.
Oh, okay.
Yeah. So
There's actually one. So equation of means that find the linear system in the unknown.
Yeah.
Right?
did you?
Solution.
Yeah. So if you see this second exercise, wait. So this was our question. For the second exercise, you had U, the equation, and you had W as general point. This is general point. So I calculated U by this method. Normally solving the equation, I got U as this, and I got W by taking out the common for all the steps. I got W as well. Then this is most important. You had U intersection W. In this case, we had okay. For the U intersection W, that means that you are finding the common solutions in between them. If you have equation of U and if you have equation of W, you can put them all together. Then you find the solution. You will get the solution that we'll get is u intersection w. You will see the video and you will get it out. But in our question we had one equation that is for u and the other is a generic point. Idea is to take the generic point and substitute in the equation. Then you will get some values for a, b, c, d. That is our generic point for u intersection w. So what I did, I took the generic point, I substituted in the equation of u. So I got some relation. The relation which I got is b plus c is equals to 4 times of b plus c. 1 is equals to 4. That is not possible. So there is no common solution. So u intersection w is 0. And you will analyze. You will see the video. I have I have like marked out the important terminology or the idea how to see the solution without even solving it, like how to identify the number of dimensions, how to like know whether you are doing correct or wrong. So you have the full video, you can access it. And for you sum w, you just put all the solution in a row epsilon form. You try to eliminate the linear dependent things, and the final one you will get is u plus w. Okay. Yeah, you just put the basis of u, put the basis of w, eliminate the linear dependent one, like eliminate the one, you will get 0 0 0 0. So if you eliminate them, finally you will get like 4. So it's the dimension will be 4. You will see the video. And also for the question number 4 you have to go through the video. Now the final exercise was find the equation of w. As I said, you try your own, then we will solve it, and also we will address this question later.
Okay, well, I haven't got a clear idea of how to.
It's okay. We will address this one later. Let's do the last question.
Doesn't have anything to do with the last question.
No.
Okay, so this is we have to solve.
We will solve it. Okay. Coming back to our original idea that which we are doing right now. Okay. Your question from, okay, since professor said that he will also ask complex number, so that means I am imagining first question as complex number. Second question as linear map plus the concepts of diagonalizable and eigenvectors. It will use everything, advanced linear map basically. This is a basic, that one will be the advanced linear map. So for in the first 2 bit it will cover everything. And the second question will be find out u, w.
This will be the first question, both of these.
No, this is the first question.
But
I'm hoping.
Wouldn't it be too simple if it was just complex numbers?
Yeah.
No, I think if he asks complex number, so there will be one dedicated question from complex number. The way
because
we do.
This is the first year that complex number.
No, the complex number was there in calculus, so he will just take that calculus question and put it over here. As I have not seen what they have taught you in the complex number. I will check it out.
Yeah, I remember in the second call of calculus we had 2 possibilities.
Yeah.
For the students of the previous year, they had to solve the complex numbers.
Yeah.
So it's actually in our linear.
So in the third question, it might ask you about u, w, that one that we did right now.
Okay, yeah.
U plus w, u intersection w, maybe u orthogonal, w orthogonal, and all these things. You will see how to find orthogonals. Yeah, it's the last part. Also, it might consider some like of eigenvectors or something, I don't know. But the fourth question will be affine geometry.
What?
Affine geometry.
What's that?
Affine transformation.
The transpose matrix.
No.
The last chapter.
The last chapter. Intersection of 2 planes, intersection of 2 lines, one line, one plane.
Okay.
Yeah.
Yes,
Those
you
figured
clear
out
that.
the last chapter.
No, that's the easy one.
That's easy.
Yeah, it's just imagination and you're done. So if you understand this three, not this one, this two perfectly, this will take very few time.
Okay.
Because again, affine transformation, the idea is like you have to use your brain for the geometry, and if you get that idea, rest is algebra. Rest you will use only these things.
So for the first question, we also have other possibilities. We might have some questions from vector spaces or
No,
like
the vector spaces are included here.
Here, okay. For linear systems.
Raspberry.
Also for the linear systems.
Yeah.
So,
Cigarette भी था. Yeah. Cigarette break लेनी है.
Okay, we can do that.
So in the one question, there is a combination of different.
Okay, so exercise 3, this is on linear maps, but very basic. Because in the second partial exam you will have bit extra, since he will not repeat any question from partial 1. He will just add a new topic, a complex number. Are you sure it's 5 questions or 4 questions?
Oh, in the partial. In the final.
In the final exam. Because if it is 5 questions, so there will be one more basic.
4, I think.
Yeah, I think 4.
Okay.
Yeah.
Just confirm once again whether there will be a question from complex number or not.
Okay. You're not asked right now.
Okay, so the map, you can do it later.
Okay.
Like instead of asking your friends, you can directly email professor. It's R3 to R3. Okay. And the function is given in such a way as x, y, z is x plus 3z minus 3 x4y minus z 2x minus y plus 4 times of z. Okay, this is a relation that is given. First question, find the kernel. Do you have any idea what is kernel?
Kernel is the equal to 0.
Yeah, the map which you see, like if something over here, okay, that goes to 0. That means all these 3 will go to 0. So x plus 3z is equal to 0, minus 3x plus 4y minus z is equal to 0, 2x minus y plus 4z is equal to 0. So you can solve this equation to get the kernel. Again, you use the concept of linear system.
We could solve this system by Gaussian elimination.
Yeah.
But can we solve it without Gaussian elimination as well?
I said you can do with the substitution method, but if whenever you have like more than 2 variables, use Gaussian elimination. କହିଲେ କିଛି ଇମ୍ପୋର୍ଟାଣ୍ଟ ଅଛି କି? କିଛି ଇମ୍ପୋର୍ଟାଣ୍ଟ ଅଛି କି? ମୁଁ ଅଛି କ୍ଲାସ୍ କରୁଛି ତ। हाँ आने दे।
ये तेलुगु है?
नहीं, ओडिया है। Okay. So we have to do the Gaussian elimination. You can multiply 3 and add it over here. 0. 4. If you multiply 3 is 9 minus 1. 8. Then if you multiply negative 2 and add it over here. 0. Negative 1. If you multiply negative 2 is the negative 6. Negative 2, right?
Yes.
And if I multiply negative 2 and I write over here,
And then we can also just divide this by 4 for simplicity.
Not now.
Not now.
I suggest you don't do anything right now at the end.
Okay.
Yeah, you can do it, but
You
I
actually
pref-
dividing this
I yeah
multiplying to 1/4.
yeah
Okay.
negative 1/4.
Negative.
No, not negative 1/4. Yeah, negative 1/4.
I'm adding it to
Yeah.
first.
Then you have one free variable, that is x3 is equals to x3, x1, x2, x3. So it's one free variable, x3 is equal to x3. 4 times of x2 plus 8 times of x3 is equal to 0. Now you can do it. Also you can do it here, but I don't suggest you to do it there. Sometimes you might make mistakes. 2x3 is equal to 0, so x2 is equals to 2 times of negative 2 times of x3. Okay, did you understand? I just from this line x3 is equal to x3 is a free variable, belongs to R, and I wrote 4 times of x2, 8 times of x3 is equal to 0. I just took this, I just divided like 4 all.
Okay.
Yeah. If you take out 4 common and take it to that side, so 0.
Okay,
Then from the first equation I got x1 negative x3 is equal to 0, no, negative, positive. Okay,
x1 plus 3x3. Okay. Okay. Yeah. This is a particular solution.
no, it's a free variable. It's a homogeneous equation. How you will get
Okay,
it?
we have infinitely many solutions.
Yes, so that's why I'm writing it.
What is it called? So,
It's a general solution.
general solution.
Yeah, it's a homogeneous equation, so there is no chance of a particular solution. Either you will, this is a homogeneous equation,
Okay.
right?
Yeah.
There are two possibilities.
Two
Either you get a unique solution, that is trivial solution, that is 0, and the other one is infinite many solution. And
Infinite.
as I said, whenever you will have
Okay.
no free variables, you will get like one just trivial solution, that is 0.
We
You
have
have,
free
you have to
variables.
solve those 5 exercises. Okay.
They don't look difficult. They just
Yeah, this look easy, but you will have a clear idea.
Okay.
Like, so that in the exam you might not get stuck. Okay, I have never solved this kind of question, so you will, like, I want to make you, not prone to errors.
This
Okay.
is the kernel.
Yeah, this is the kernel. The kernel is -3, -2, 1. But next question is find the image. Okay, so next question is find the image of this problem. There is several way to do this. The basic way I'm telling you, since it's in R3, okay, we consider a standard basis for R3 will be 1 0 0 0 1 0 0 0 1. You look, just wait for it. I will solve this one in two different ways. First one, I'm solving using standard basis. So when you take this one and put it in this relation, you will get, for the first one you will get 1 -3 2, right? And the second, if you put it over here, you will get 0 4 -1, and for the third one, if you put is 3 -1 4. Did you understood how? I
Yes.
just substitute x equals to 1 here and
Okay, I
in
understand.
this. Understand?
Yeah.
Okay. So then yeah, then check whether these three are linear independent or not.
By Gaussian elimination.
And wait, there is something. Yeah, check. These are your images. Check whether they are linear independent or not.
By checking if there is a
Yeah.
constant between them.
Constant. No, by the Gaussian elimination, the same thing. Like you just need to check whether they are linear independent or not. So 0, 4, minus 1, 3, minus 1, 4. So I can multiply negative 3 and add it over here. So I will get 1, minus 3, 2, 0, 4, minus 1. And this one will be 0. This one will be plus 9, 8, right? I am multiplying negative 3 and adding over here.
Yeah, right.
So this one will be 8, and if I multiply negative 3 here, is negative 6 plus 4 is negative 2, right? But you can see if I multiply, if I go from here, it's negative 1, negative 3, 2, 0, 4, negative 1, 0, 0, 0. I multiplied 2
yes,
and
that's
added over
easy.
here. So this is a linear dependent term. I can remove this one. I can remove this part as it is linear dependent. Okay. So my final image will be 1, minus 3, 2, 0, 4, minus 1. Do you understand why we do this? Okay, you see, first I started from here. Standard basis, I put these values in those relations. I got this one. But before declaring them as the images, I have to check whether is there something which is linear dependent. If it is linear dependent, it's useless to write there. My solution will be not accurate because I'm putting in the basis. So
now I remember.
do you understood?
Yes, if we turn up with a different matrix at the end, which is in row echelon, but has a different like second row, how do we?
Can you repeat once again?
If we end up with a different matrix which is not comparable to the first matrix, how can we say that we eliminate?
No, I took the position over here. So I checked if this one, if I didn't change any position of any row, I didn't swap this one to this one.
Okay.
So I know I'm dealing with this.
So because this one is turned 0, you just eliminate.
Because I didn't swap any positions.
But if we do end up swapping, will we
you should remember like which one you
swap?
Yeah, but if you swapped something, you can also write whatever you get here. You don't need to think about this one. For example, at the end you have swapped like maybe 4 times, or I don't know. So you just end up with A B C D 0 0 0 0 E F G H 0 0 0 I. You don't need to think whatever it was. You can just write it A B C D comma E F G H 0 0 0 I. It doesn't matter. You take the original one or you take this one.
So over here we could have also write 1 minus 3 2 and 0 4.
Yes, here in this case it was simple, so I didn't change this one. So
whatever row which is 0 will be eliminated.
Yeah. Okay. Again, it will check if you write this one or if you write the original one, they are conceptually same. Because anything you are putting it over here is not just that number, is the linear combination of all the possible cases.
Yeah.
Yes.
Got it? Okay, if we see what was the dimension of our kernel, is 1, right? Number of element over here.
Number of elements. Yes, 1.
And what is the dimension of image?
2.
Exactly. And in which R space we are doing? It's R3, right?
Yeah, I don't know why 2. I just know because I remember that I solved a question. I counted like
Yeah, whenever you have you remove the linear
number of-
dependent,
yeah.
the final thing which is in the basis is a dimension. We got one thing, we are dealing with R3, right? So the dimension of R3 is 3. So this one should be
Yeah, that's
What?
this is the relation. The dimension of R3 is 3. You got the dimension of the image as 2 and you got the dimension of the kernel as 1. So you just want to verify whether it is correct or not. It's correct.
Oh, okay.
So
this is a
But how do you find the dimension of the image again? Like, I just don't know why I said 2.
no. You took the image, you find it out, then you put it, check whether they are linear independent or not. So dimension is after removing the linear dependent terms, how many steps you are remaining with.
So we have 2 independent terms, so we write 2.
Yeah, or dimension is the how much number of elements, how many elements you have in the span of the vector space on the basis.
Okay.
Got it?
Yes.
Okay. The another way to do it
So
in this,
dimension is I got confused upon this once. Like, dimension is not equal to or similar to rank, but in some questions it's same as rank,
yeah.
right? Because dimension could be different than a rank.
Rank of a matrix is the number of independent terms you have. Dimension is the number of elements there in the basis.
But the number of elements would be equal to the number of.
For example, okay, let me ask you a question. For example, you have an equation, some 3 equations, okay, is the equation of u. I ask you what is the rank of u and what is the rank of the matrix, the elimination, the matrix that you will get here, and what is the dimension of u. So rank is like when you put it in the Gaussian elimination, you check whether okay, how many are 0. If you get something 0, so the rank decreases. Dimension of u is like after solving it you might get some solution here, right? You will get some
In dimension, for example, the case that we had, like if alpha plus 6 equal to 0 and if alpha is not equal to 6, would that matter for the
no,
dimension?
dimension is inside the basis. Rank is in the matrix. Rank is the number of steps that you have in the matrix. Dimension is like you
Rank can be like changed if we equal to 0 and if it, like we did over here. Yeah. So, for example, if 0 is not equal to alpha minus 6, then no solution.
actually what is the relation between rank and dimension.
I wrote it down like
So, for
4 days
example-
ago. I
for
literally
example,
wrote it down.
Imagine
I
you
forgot.
have a u, okay, and you got some u is in R3, okay, u is in R3, but you got your rank as rank of this, the equation that you had, and you put it here, and you got rank equals to 2, okay. That means you have one free variable, okay. I'm not solving, I'm just using the concepts, okay. If you don't get my idea, just say me. You have one free variable, okay. And if you have one free variable, so there will be just one basis, the solution will be in multiplied with that free variable, so your basis will be 1, right?
Yes.
So the dimension of u equals to 1, but the rank was 2.
2.
So you can say rank of u plus dimension of u will be equals to the total dimension of R3.
Yeah, I spent like 1 hour trying to understand this from DeepSeek.
Now,
can
did you
check
understood?
always whether it's true or not.
Yeah.
If we have this one always, but either we have this or this, we can check.
Got it?
Yes.
जा रहे हैं भैया? ठीक है. मीटिंग है ना आपका? Yeah, that's it for the dimension and the image and kernel. Now we will do the next bit. Okay, I'm just writing the question because my laptop can switch off and I need to bring the charger. Consider a vector w that is 1, -2, 3 and find the inverse of w. Okay. Okay, find the inverse of w. F inverse of w. So here you have the reverse case. You have like this is our x plus 3z is going to 1 minus 3x plus 4y negative z going to -2 and 2x minus y plus 4z is equals to
3.
3.
This
So
is the t by writing 1.
which one?
We just t minus 2 1.
No, we're doing the second part.
We're doing the second question.
Okay.
So here this will equal to this one,
Okay.
this will equal to this one, and this will equal to this one. So find the f
fine.
inverse.
F inverse is pretty much.
Yeah, it's like finding x, y, z, the same thing.
Okay.
So here you will solve it.
You just have to find x, y, z.
Yeah. You will do it. I will not do it. I am skipping it because it's again solving the linear equation. Then you will get x, y, z is equals to something, some particular solution maybe, or any case I don't know. It is a non-homogeneous. It's a non-homogeneous equation. You might get a particular solution and a general solution, or you might get just one particular solution or no solution. So there are 3 cases. It could be any of these 3. You have to solve it.
Okay.
Next question is consider for t belongs to R. Okay, consider the vector t minus 2 3 for what value of t, for what value of t v will belong to the image. Now it has several methods to do it. What was our image? Can you tell me the basis of the image? So our image was so this was our image, right? The question asked you like, does this thing belongs to, okay, does the vector t minus 2 3 belongs to this image, the image and indirectly it is asking for what value of t it belongs to the image. For what value of t it belongs to the image. So it's basically the simple question. If this vector is x1, maybe this vector is x2, so it is asking me for what value of t this vector v, this is the vector is v belongs to v equals to alpha times of x1 plus beta times of x2. It is just asking for what value of t. The v is the linear combination of x1 and x2. So again, I suggest you to do the best method possible is this one, 0 4 minus 1 t minus 2 3. So if this last line, imagine if this line becomes 0, what does it mean? That means there is a possibility that this line can be written as the linear combination of these two. Finding alpha beta, doing this thing, the same thing.
Which means it's linear
Yeah.
independent.
Yeah.
Force.
So the first step, I will try to make this one 0. So
You can
I will multiply 1 over negative t. Okay, this method will be complicated over here, I guess. Okay, multiplying
you can do one
my
thing.
r3 is equals to
You can do one thing. If you subtract this from this is minus 6, then you can add 2 times of
anyway
this.
I have to deal with this t
Oh,
first.
okay, T.
So
the
if
T's
I
are
do-
any value.
Yeah, if I do this, I can make this one 0.
Minus 1 over T.
But won't these become t's?
Yes.
Yeah, it's okay, but I'm doing with the approach, but there is a mistake here.
There's a mistake over here.
Yeah, identify the mistake.
T might be 0 also. So
Yeah,
it's-
so
yeah.
if t not equal to 0, I have to write my statement will be valid if t not equal to 0. Okay, so
For any value of T, this is T's.
yeah, but for now I'm analyzing for t not equal to 0.
Okay.
Then I will analyze for t equal to 0. So if you do t equal to 0, it's pretty simple. If t equal to 0, that means this is equal to 0.
And
And-
then we can do what I said actually.
Yeah,
This will be the.
But anyway, there will be all the 3 rows. Even you eliminate this one, this will not be eliminated, right?
We want also this to be 0. So we
Yeah,
want
so
a
it will
linear
be
combination.
not 0. So for t equal to 0, v doesn't belongs to image.
Okay, this is also a possibility.
Yeah, and rest possibility t not equal to 0, I can do it right now. Okay, so I can write as 1 negative 3 2 0 4 negative 1. Okay, that was t actually, so it's 0. Okay, and if I multiply negative t, it's like 3 by t, it will be 3 by t plus minus 2.
Okay, great.
Then here it will be 2 by t plus 3, right?
Yes.
Or negative?
No plus.
Negative.
We are adding this to R3.
Yeah, I'm multiplying.
Multiplying minus also.
Yeah.
Negative.
Again, I have to make this one 0. How to do it? I want to make this one 0 actually. So I
So
can.
this should be 2. Actually, 2 to be 0. 2 minus 2 is 0. I don't know how to make it.
Yeah, but anyway, I have to.
Okay, so it's,
Yeah. So I have to.
you can put it into one.
No, I can do one thing. I can with R2 I can divide by 4 so that it will become 1, and I will multiply negative of minus 3 by 2 into R2 plus R3 is equals to R3. Possible? Did you understand what I did?
First you divided the second row over 4.
4
And then you multiplied it to this.
a negative of this, and
Negative
whenever I
of
will
this.
add this one, it will become 0.
This will become 0, but not this.
Yeah, I don't want to make that 0 right now.
Okay.
And my idea is make this one 0 first.
Okay, so this is 0.
Yeah, so what will happen? 1, negative 3, 2, 0, 4, negative 1, 0, 0. But this one will be, I have to analyze. So this one will be negative, negative, positive. So it's 3t by 3t minus 2 by 4. Okay, so if I plus this thing, first I am simplifying this term for easier one. So it's 3 minus 2t divided by 4t. Is it correct? I can write it like this.
Yes, correct.
Then 3 minus 2t 4t plus 2. It's like this.
Yes, it's correct.
Yeah, so again take the LCM as 4t all over, so you get 3 minus 2t, and this one will be 8t plus 8t, right?
Yeah, right.
And if I multiply 4t is 12t,
Yes, right. Again.
and I will get 3 plus 18t, 3 plus 18t divided by 4t.
18 plus 12
No,
plus
8
2
plus
is 3 minus 2t plus
20 minus 2, 18. Okay, 20 minus 2.
This is 8. Yeah.
Yeah.
This is
Okay.
good.
So it's 3 by 4t plus 18 by 4, and is something 4 point something, I guess.
Okay, yeah.
So I got this one as okay. So if this thing becomes 0, this v belongs to image. Correct.
Yes, correct.
Yeah, we are doing very simple. So you see, the concept of the first class we are using everywhere.
Yeah.
Yeah.
That's the first basic thing.
Yeah. 18 by 4 is equal to 0. Then it's like 3 by 4 t is equals to negative 18 by 4. 4 cancel. 3t is equals to negative 18. T equals to negative 6. So if t equals to negative 6, if t equals
belongs
to
to
negative
image.
3, v belongs to the image. Okay. That's the third question. Fourth one I think is the same one. Okay. Question number D. For the values of t that you found, we got t equal to 6, right? Find f inverse of v. It's easy.
Now we just need to put minus 6 over here and so
Yeah, put minus 6 equal to here and do the second question.
Okay, basta.
Did you understood the question? It said for what the value that you got over c, in the bit c, find f inverse of v. It means you have minus 6, you have v equals to, for this question you have v equals to minus 6 comma minus
F inverse
and
of
we
that
need
one.
to find f inverse of this.
yeah.
Okay, so this again this.
This is homework.
Yeah, so this is homework for sure.
Yes.
And I will give you some list of questions that you need to do by tomorrow.
Okay.
Also, I suggest you access the Moodle of the professor. There you have the sample question for the partial one.
Yes.
Like he had uploaded. I will send it to you as well.
Okay.
He had uploaded the partial question. So do that paper.
Okay.
Okay. Stopping the video here.